So we're going to have f is continuous on the interval AB. So let me draw the graph. My y, and I'm going to lay my horizontal line t. Then we have this function, which is y equals f of t. And then we're going to have our endpoints. We have A, and then we have B. Then we're going to have another variable x, and then under the line, we're going to have to find the area, which is the area under the line. So for that, we're going to have to use our integrals. And so the integral for this function would be a to x f of t dt, where x is in the interval a, b. And this is like going to equal our big F, t. And in order to change it from the t term into the x term, we're going to use what is called the, right here, the fundamental theorem of calculus. This is where we're going to have df over dx equals d over dx in the integral a to x f t dt, which is going to equal fx. So basically, every continuous f has an antiderivative, which is big Fx. And then the connection with the fundamental theorem, it shows the connection between derivatives and integration. So we're going to go on to our first example. We have example 1, which is our general equation. We have g of x equals 2 to x 1 over 1 plus t3. And how we have our 2 to x and we have a t term, we have to make the f of t term turn into the f of x term, like in our equation of the fundamental theorem of calculus shows up here. So to turn it from the t term to the x term, we're just going to plug in our x's for t. So this would basically equal 1 over 1 plus x cubed, which is basically our answer. But if we're trying to solve for something like, say we're solving for g of 2, which is 1 over 1 plus x cubed, we're going to plug in 2 for the x, which is 1 over 1 plus 2 cubed, which equals 1 over 9. And this is basically how we solve for it. So let's try a more difficult problem. We have our last example. We have d over dx pi over x cosine 2t over the natural log of t minus the square root of t dt. And from the beginning, we just changed the t term function to an x term function. So plugging in all the x's for t, so this would equal cosine squared x over ln x minus the square root of x. And if we're solving for the problem, we'll just plug in pi for this new equation. So we have cosine squared of pi over ln pi minus the square root of pi. And so you can leave your answer like that, or basically, or solve for it, but I'm not gonna solve for it, sorry, and go through all that math. And so that's how you do the fundamental theorem of calculus by Alaysha. Hey, hold on. Green.